How's everybody's morning? Do we have anybody in China? Their night?
Yeah, the time zone's been hard to crack. We've sent a couple of surveys, but it's hard to find this time that works for everyone. Yeah, we got one. Far too many Jameses. All right, let's kick things off. Uh, our first speaker, Stefan, is going to talk to us about InstantDB and their journey writing a graph-based sync engine. I'll hand it over to Stefan.
Hello, everyone.
Hey, hey.
Let me find the correct thing. Here we are. 1080, 30. All right, we're live. Now I'm gonna play this.
Coming in great.
Awesome. Okay, how's everybody doing?
Pretty good, pretty good.
All right. So, hey guys, today I'll talk to you about building a graph-based sync engine. So, just a bit about me. I started my kind of professional career in 2014 at this startup called Wit.ai. We were this small team. I eventually joined Facebook. Throughout all this time, I've been working on kind of front end to back end applications. And eventually, I started a company called Instant. And here I'll just kind of talk to you about the journey to that. Right. One thing that's kind of funny about all this is, you know, everyone here is local first. I'm also local first. It's interesting to see how we discovered this. Right. So for me, the journey was a little bit circuitous. So I think the way it started for us is all about productivity. So if you look in the 2000s, how did we make apps then, right? It was actually a lot pretty simple, right? You'd have a database, you'd have Rails, and then you'd have screens. And this felt pretty productive, right? This is how it felt. Uh, but things started to change, right? Even during the Rails era, we had Basecamp, Zendesk, GitHub. All of these were built in months, right? But this wasn't quite the same anymore. What changed was web browsers just got a lot better, right? In 2003, like there wasn't even good JavaScript in the browser, right? So most of the work was happening on the server, and then networks got better. This meant that we had kind of like a new kind of application, right? Instead of having things like GitHub, or Jira, we have apps like Linear, right? So like, what are those differences, right? At this point, I hadn't even really discovered local first. But when you kind of look into what makes them different, the first thing you notice is optimistic updates, right? So if I'm making a change to a to-do, I don't want to wait for the server, right? Once I click it, I just want it to show up right away. And then immediately after, the server needs to know about it, right? And when you do things like this, all of a sudden you get flow, right? Similarly, multiplayer, right? If I'm trying to make a design document, right? I used to have like a bunch of different files, right? But this wasn't a very fun workflow. Well, Figma comes around, and turns out when everybody has the same file, it's like a much better experience, right? And turns out it's not just Figma, it's like even editing the same to-do is a much better experience, right? Much more fun. And the third thing, all of us can relate with is offline mode, right? And you go on the plane takes off, right? You're writing like an important document. Hopefully, it just works, right? If it doesn't, you can't really have like a second brain experience. But no, not only is this like important for having this second brain experience and trusting your data, but it's actually a lot faster too, right? So if you have a Notion and you load it the first time, maybe it takes 200 milliseconds. But if you load it a second time, it's like instant, right? So these are the modern features. But the problem is if you just have the infrastructure of like a single server, like Rails, and then you have like a web page, it's just not gonna you're not gonna be able to implement these kind of features. Right? So the problem is these are features becoming table stakes, right? But building them is still very tough. So how do you build it today, right? Like, what are the options that what do people realistically do? And this is kind of the way we started. First, just look like how do we read data, right? Now we have a database, we have our to-dos and teams, right? And then all of a sudden we have endpoints like get to-dos, get teams, right? And then ideally we should be able to draw the screen, but then we have this kind of like a permission layer, right? But then if you get teams and to-dos, users might be shared between, for example, a to-do, right? And if a user changes their favorite language, you want it to show up in both places. So now we have to normalize the data, right? And then this means we need like a store, right? And now we have screens. We want to paint the screen, but screens are kind of nested structures, right? So all of a sudden we need to denormalize the data, right? And this is just to paint one screen, right? And what do we do when we write data? Well, let's say I delete this to do. I make this endpoint, I go through the permissions, all these things. But then how do we update the UI? Right? Okay, well, we do delete, but that's not going to change the UI, right? We could refetch everything, but that's like going back to Rails, right? If we do it ourselves, what we do is we kind of say, okay, delete the to-do in the to-do store, delete the to-do reference in each team like this, right? But when we do this, like what's really going on, right? We need to ask ourselves, when you delete a to-do, what happens, right? And then we kind of do like a garbage collection in our head. Update the to-do store, update the team store, update the metric store, right? Let's say you had a graph of to-dos, you need to update that too. And then all of a sudden this just gets more and more complicated, right? Our brains weren't meant to be like garbage collectors, right? That's what garbage collectors are for. Similarly, like optimistic updates, right? Like let's say we want to make this transaction faster. Well, now instead of deleting it first, we would just delete it, um, optimistically. But if we do this, how do we do rollback, right? Well, if we do rollback, now we need a try catch, right? And then we do the rollback here. But this is like, even more things to remember, but that doesn't actually fully solve the problem too, because imagine you have something like this. I create a to-do to wake up. I save a to-do, eat snacks. Save a to-do, hack, right? The first one works, the second one doesn't. If the way I wrote the code before, if I read that naively, ideally it should say eat snacks, but actually it'll say wake up because the undo will remember the reference for the first to do, right? So the way you solve this is you use queues. So now, instead of having like a normal screen and a Rails controller, now we have a transaction queue in the front end, right? And we do save to do, delete to do in a queue, right? Then how do we make this multiplayer, right? Well, instead of endpoint, we need these to be sockets. But just doing that is not so simple, right? It's nice to put it in a box, but what's inside, right? The main thing you need to solve, this is what most of the kind of companies that do this by themselves do, is they create this idea of like a topic. So what page cares about what? So for example, maybe the team page for the team A cares about this topic, or the user page cares about this, or the task list cares about this, right? Now, um, what you do is whenever you save a to do, we're just going to generate task list B, user page A. But how do we do that? Well, okay, we have this function in the backend, right? We do save to do. Now we need to figure out what topics. And again, we start garbage collecting, right? When you save a to do, what topics change? Maybe the task list, maybe the team page, and then it just keeps going on, right? And you're in a bit of a quagmire because if you get too general or if you get too specific, you have tons of topics. But if you get too general, then you're just going to get really slow updates or tons of updates are going to go to the page, right? And then you write, I guess you do all that work and then you run notify. But how does notify work, right? In a simple system, maybe you have one server, you can find all the sockets. But what if you have multiple servers? Okay, actually what we end up needing is instead of a normal Rails HTTP server, we'll need a queue here too. So maybe we listen to the write-ahead log, right, from the DB. And based on that, we can find all the sockets on each server and then send those updates, right? Are we done? there's race conditions too, right? This is what Thomas been talked about for linear. Okay, like let's say you're bootstrapping, you do get teams, and then you subscribe to team page A. It's possible that there's a race, you miss data while one is connecting and the other one connects, right? Then here you need more queues too, right? Already this is a doozy, but we're still not done, right? How do we do offline mode, right? We actually have, thankfully, a lot of the infrastructure already, but you need to add InstantDB, right? And you need to store the transaction queue and all the data that you have in the store, right? So when you do all of this, then you have like how much data do you store? How do you store that data so it's easy to access? How do you only load it partially, right? If it's partially, how do you load more, right? And how do you schema migrations? So if you solve all of these things, you have a modern app. And that's kind of how we started trying to attack this with Instant, right? Instead of an infra team, could we just create a general solution, right? And that's what we actually did. And the way we started was just looking at this structure here, right? And say, what is this really? If you think about it, you have a bunch of queries and you have a bunch, denormalized is just queries. The store is like a DB. IndexedDB is also a DB. You know, transaction queue is kind of like a write-ahead log. Sockets or queries that look like partial replication almost, right? That turns out, a lot of these problems are just database problems in disguise, right? And that's what we ended up kind of creating. So screens, you can write queries, you can those queries subscribe to a reactive layer on the backend, and we have a global database that interacts with that reactive layer. So I'm gonna try to run through because I realize I'm coming close on time. Just let me know, guys. I'm looking at my phone. So if I'm too slow, let me know. But let's go ahead and build this. First was choosing the query language. How do you make queries on the front end? The most simple one would be to start with SQL. But if you do SQL, then you need to have SQLite, which is a big bundle. But the biggest problem is how do you make that reactive, right? If the spec is 1,700 pages, like, can we support all of those things and make every query reactive? It's kind of hard, right? So what we did was, okay, well, look at the front end queries, right? I'm just going to skip this part. Look at the front end queries, right? A lot of them are just graph queries. Team A has tasks, which has users for linear or Notion, blocks, connected blocks, or Figma. Documents have layers, right? And these are graph queries, right? And turns out you can represent graph queries pretty easily using this idea of a triple, right? You just have an ID, an attribute, and a value. And then through this, you can even have relationships like team one has a task one, right? And it turns out, writing a query language for this is really, really, it's not as difficult as SQL, right? You can write one in 100 lines of code. And I have an essay about how you can just do that. Right? So that's what we did. We chose Datalog as the local database. But the problem is Datalog looks kind of like this, and most people don't like this, right? So what if we made it more friendly? And that's what we kind of added on top. And InstaQL is this new kind of language that we made for this, which looks like GraphQL, but it's just data, so you don't have to have a build step. This is how it looks. You just say teams where ID is one, or give me tasks, give me owner, and this just kind of gets all the data, right? And you can see if I have this query, right, I can actually just generate a tree of data log queries. And this is what we do under the hood, right? Now that we have this way of writing queries in the front end, right, how do we make all these queries reactive? Well, remember the topics, right? Whenever you made a change, we just kind of generated these like taskless D topics manually. What if we could just do this for you, right? And this is actually what we ended up doing. All right. So if you look at this query, like give me all the users where the handle is Alex, you can kind of generate a topic that looks like if anything changes around this part of the index in my database, let me know about it. And that's kind of uh, how we created a topic, right? And this is a pretty complicated diagram, but on the back end, this is how it works. We listen to the write-ahead log, take an item, and then we can generate the topic that can invalidate a part of a query, and then we can send the data back to the client. right? This is actually inspired by Figma Live Graph and Asana and Luna. This isn't something we kind of invented in-house, right? So that's the reactive layer, right? And then we needed to do permissions, right? How do you make sure you can only see what you're allowed to? The problem with permissions is we need to run like user code. Well, it turns out like literally a year ago, Google released this thing called Cell, which is this awesome library that you can write kind of like expressions as a user, right? And then we can run this in our server, right? And it's embeddable and it's fast. So we ended up plopping in Google Cell, and suddenly we had kind of like a good reactive layer. And then of course you need auth in order to make permissions make sense. So we added auth, right? The final piece of the puzzle was how do you make it so you can store all the data for all these different apps, right? We didn't want to make it so um, you'd have to like pause your database, even in a free tier. So what we did was we actually just created one global database for everybody, and it's running on top of Aurora Postgres. And all the data for the users is stored in one table. So it kind of looks like this: app ID, entity, attribute, value. And the key is the app ID, right? So here, when we had all this data for the team for Joe, for example, we could just prepend it with app ID, and boom, like now we can just have this one table grow, and Postgres is good at growing tables, but serve multiple users. The problem though is like how do you do kind of relationships in this model, right? It's actually, if you look at it, like give me task for team one, this kind of works out of the box, right? App one, team one. Um, you can use an index to get this. Uh, and this index here in our table is called EAV. But if you say give me team for task one, it's a little bit different because you see here the team one is in the middle, in the beginning of that. So you can't use a B tree for this. So what you can do though is you can just kind of reorder it, right? And all of a sudden it's really easy to go in the backwards direction too. And this is called a VAE index in our database. And this is just prior art too. Like this is just how triple databases um, do kind of relationships, right? And one kind of way that we're able to do this is Postgres has this feature called partial indexes. So we can just add little flags in the row that let us decide how we want to index this data, right? And that's kind of instant currently. What we do is on the front end, we have a database that understands triples, and you can write kind of these GraphQL looking queries that goes into a reactive layer, keeps every query active. You have auth, you have permissions, and then the very bottom, all the data is currently stored in this one big Aurora table. All right, that's that's me.
That's awesome. And you really laid it out
What's
step
that?
by step, and I really enjoyed listening through it. Kind of how to get
Cheers.
to
I can.
InstantDB.
Oh, heck yeah, guys! I couldn't tell. I was usually I can see the people's faces, so hopefully that wasn't too fast.
No, it was great. If you start, there we go. I realized I didn't intro you when we started. This will work as a great recap. That was Stepan. You did a great job breaking it down for us on all the different ways you kind of all the layers that gets you to InstantDB. Really enjoyed the talk. Next up, we have James Addison. Um, he's a repeat speaker, one of my more interesting people in my Twitters. He always has some great content and little snippets of malleable stuff. Shapeshifting, I don't know what that means. Maybe you can kick it off by explaining that to us as well. Over to you, James.
Thanks. Sharing my screen. Okay, everyone can see okay?
It stopped sharing just when you
Um,
did that.
huh, that's weird. I'm gonna quickly close it and reopen it and see if that helps.
Yeah, no problem. In the meantime, just have his kind of blurb up and running. The last time around,
Yeah, let's see if this works again. Great. Everyone can see now?
Yep.
Thanks for having me.
Yeah, of course.
So my name is James. If if you haven't heard of me before, I'm Silicon Jungle on Twitter, which is probably the place I'm most active. Today I'm going to be talking about shapeshifting media, and what I mean by that I'll get into throughout the talk, but it's really at the intersection of AI and collaboration software and how these two things intermingle. So today we have these tools that allow us to, type in a prompt and get an image of a red panda, or include a picture and a prompt and get a video using something like Luma Labs. But there's heaps of different ways that we can do transformations across different modalities. So we can transcribe text, we can, do OCR and get text out of images. Some older demos that I did, I was working with, TL Draw's whiteboard, and I draw some pictures and then turn it into a 3D scene. You can generate color palettes, depth maps. This one in the bottom corner is I originally got an image and got it to be described, and then generated audio from that, and then mapped the audio and the text together. So you've essentially got this way for, people who have, maybe they're blind, or maybe, they're deaf or something. You have many ways that you can consume this same media. All of this is to say that what I think is happening is the boundaries between mediums are shrinking. So here I've gotten a picture of a spider monkey and a chimpanzee, and I've turned them into 3D models, and I'm able to move them around this scene. But this idea is much broader here, right? So I think with this diagram, I've got a picture of a chimpanzee, and then there's a 3D model and a video and a depth map and text and audio. And all of these things are pointing at this underlying idea of what a chimpanzee is. Now, what I think is interesting about this is it's not a mathematical, representation. There's no direct translation. All this stuff is kind of probabilistic. Because when I say, like, this is a red panda, what I mean by red panda could be very what you mean by red panda. And every medium has their own strengths and weaknesses that we need to be able to lean into. I think a very famous one here is like when you're reading a book, and then you see the movie and you're like, oh, the book was better. And like sometimes that's true because the mediums have different affordances. Some are more about thought, some are more about action, etc. And so where does this fit in with local first space? So this is a picture that I pulled from Joffrey Litt's Twitter when he posted about a project called Patchwork, which is meant to be universal version control. And so the diagram on the left is a typical design for OT. So in this case, this isn't always the case with OT, but in this case, the centralized server is the authority. So whenever anyone makes a change in the history, it's merged in, and the server has the last say on like the ordering of how events played out. But Git and many CRDTs are starting to go down this route of whenever anyone makes a change, those changes are from the perspective of the person who made that change at that point in time, which means that you can replay the history, not just from a single unified point of view, but from the point of view of each person as they're making those changes. Now, where does this come back into AI stuff? So my conception of where I think some of this stuff is going is that I think that version control, and I want file systems to work this way. It's a bit more of a stretch, but I want files to be multimodal concepts or ideas with histories baked into them. And so if I'm editing a podcast like in Descript, and I have an audio file of a recording, like let's say we've got the audio recording of this right now, and I want to open that file in a text document, I should be able to right click on that and go edit in text document and make some changes, and it will learn from my existing voice and like insert new text or delete it. But you can imagine this idea of like being able to open this same file in an image editing piece of software or etc. Right? And I think there's this older term called like bring your own client. Right? What I want from this is bring your own modality. And the reason I want this is because I think that people are better or worse at expressing ideas in different ways. You've seen these demos with TL Draw where they draw a picture and then they press make real and it creates real software, right? Some people are better at expressing ideas like that, and other people are better at expressing ideas using VS Code. And there's no reason why I think that these people shouldn't be able to collaborate together. Okay, and so I want to talk a little bit about how I think this plays out. So, firstly, this idea that each point in time is a change from the perspective of a user, right? When you go into multimodality and say that like what you're modeling is actually the underlying concepts, how I depict it right now is that at each point in time, you have a solid piece of media. Like the piece of the image of the chimpanzee might be a commit at a point in time, but then someone else might transform that into audio or into text, and that's just another commit into the causal tree. Which means that you always have these solid conceptions of what you're working on, but it's just flexible and you're able to it's got the shared history across different modalities. So some of the things that I think are happening with AI at the moment is that, we're able to control these features at a much higher level. So this is a demo by someone named Gaitis. I don't know how to pronounce his last name, Jojotis or something. And you can control features directly in images. So there's like more fisheye lens or Golden Gate Bridge or sunsets, but it's not just in images. Like I made this demo where you can interpolate between different pieces of text. There's also ones where you can like extract out the idea of fear and then interpolate text towards that. And then I've got these ones where you can like, change the mood of a character by swirling around this, this little slider, or the age and the femininity or masculinity. There's a whole bunch of stuff here. And what this is really saying is that I think the way we're thinking about media is getting higher level. So in traditional media, stuff like Robert McKee's Story, which is screenwriting, they talk about act structures. In games, they talk about difficulty curves or interest curves. Music, you might talk about emotional tone and how things change over time. I think that what we're starting to do is model these higher level semantic concepts. And that's the stuff that I think is starting to, we're starting to need to build primitives within CRDTs and other collaborative software to say, like, how has this high level concept changed within a piece of media? I'm a little bit cautious of time, but I would like to quickly jump into this here, which is just showing a couple of things relating to version control. So firstly, oh, sorry, here, yeah. Firstly, we have this commit graph, kind of like Git, and then we have a typical way of merging some media together. No one really likes merging, especially in large code bases. It's really annoying to have context. But we have these folk practices that people usually like to use if they're not that technical. They'll duplicate files and rename them like new final. We've got screenshots, we've got copy paste, we've got all these different paradigms of how people are already doing branching. We don't have a lightweight way of merging. And I think that AI allows us to deconstruct the pieces of media, the colors, the ideas, the semantic concepts within them, and remix them and merge them together. And so the folk practice of merging becomes a part of the creative process, which I think is going to bring together collaboration and AI to a much closer place. So here's just an example of like features from two images being merged together. Here's an idea where the depth of two different images get merged together so that you can have a kind of semantic water rising in the image. Got stuff like I prompted an image and then have converted the color palette from one thing to the other. And then there's some other ideas here relating to like add apples, add bananas, add both, remove things. And I'll leave it with one last note. I think that the mixed media mood board becomes almost like an integrated part of the collaboration and creative process, because when you start to collect resources, if you can deconstruct them and remix them and pull features back together, then these tools like Pocket, where you can bookmark things and save things, become resources that you can pull from for creative inspiration. Yeah. If so, that's pretty much me. As I said before, you can find me as Jungle Silicon on Twitter. And if anyone's interested in talking about any of this in further detail, I'd love to chat. And if anyone is interested in this kind of research, please do contribute to the space, because I don't know too many people who are trying to do this with collaboration software. So thanks.
That was awesome. That was awesome as usual. If there's some time at the end, we can kind of pick up some of the data. I remember there was like a lab edit or something, whatever platform you use to sort of collaboratively generate text, and some of the demos you built in. It would be great if you can show us a live view as well.
Yeah, so I'm just going to quickly share two links. One's featurelab.xyz, which is by Guidus, and then I have Shapeshift .inc. I've just sent them in the chat.
Wonderful. These things just like bend your brain a little bit. I really enjoy it. Next up, we have the original James. I don't mean to say James A is a copy, but in that James got the LoFi movement up and running for this community, the local web dev page, recent speaker, and I can't wait to hear what he has in store for us, especially because CRDTs are the easy parts. Over to you, James.
All right, thanks. Can you hear me and see me okay?
Yep, coming in great.
All right, cool. So thank you very much for the intro. I'm James, the other James. Pretty excited to be here and talk to you today. I am dialing in from Cartagena in Colombia, which turns out is an awesome city. But as always, with life on a boat, I'm hoping the internet is up to the job today. If it isn't, I don't know, jump on and shout, and I will reduce the frame rate or something. As per usual, I want to kick off with a huge thanks to Jonathan for pushing the community forward. Amazing meetup as ever. But let's get started. Okay, next slide. Just wait for the spinner. Nope, just kidding. We don't have spinners in the local first world rights. But today I'm going to run through the following things here. We've got a couple of recent updates to TinyBase, most notably its support for CRDTs and synchronization. Then I'm going to deep dive into how I managed to make some of the grungy parts of it actually work. And then, somewhat based on what I learned during that process, I think I can finish off with a couple of thoughts about what is still a kind of a to-do list for local first as a whole, because I think as a community we still have a lot to do. So those of you that are not familiar with TinyBase, it's a reactive data store for local first apps. It's built in JavaScript/TypeScript. What do all these words mean? So by reactive, what I mean is that it lets you listen to changes made to any part of your data. So you can bind your UI to the data, and basically you can really capitalize on the sub-frame rate rendering promise of local first. I try not to call it literally a database, since it just runs in memory, but it is database-like. So it features like relationships and indexing, aggregation, a query engine, and so on. And although it runs in memory, you can also persist your data to various places, files, browser storage, InstantDB, SQLite, Postgres this week if I'm lucky, and so on. And hopefully it becomes an easy way for people to get started with local first apps. Okay, so what's been happening recently? So exactly a year ago, I looked at the file timestamp of my previous presentation. This meetup last year, I talked about TinyBase's synchronization strategy, which basically involved saving your TinyBase store to either YJS or AutoMerge or to CR SQLite, and then letting those platforms do the synchronization off to some other system. So you can still do this today, but I figured like eventually I was going to have to walk the local first walk and implement some native CRDT functionality myself for TinyBase. So now there's a new thing in version 5, which is a mergeable store in contrast to a regular store. So these carry with them sufficient metadata to allow them to be merged together deterministically. And there's an API layer of objects that I call synchronizers, which also now know how to negotiate the merging of those mergeable stores together across different media like WebSockets or browser broadcast channels or whatever. The API looks something like this. You create a mergeable store, contains some data, in this case a four-legged dog called Fido. You create a synchronizer with a client WebSocket, and then you start the sync. On another machine, do exactly the same. Maybe you have a three-legged cat called Felix. Start a server. Okay, so WebSockets do require a dumb server to shuttle the messages back and forwards, but it's so dumb that the default API for doing that is literally one line of code, and this will run in Node or Bun. And ta-da! Both stores are now kept in sync, and you will see the records from both turning up in both places. So, okay, this is a very trivial example, more to demonstrate the API. And I do want to stress that TinyBase does more than just object.assign things together. Obviously, what would happen if the fields are in conflict, etc., etc. So, to make that work reliably, mergeable stores are essentially a CRDT. A regular store, a little bit like that. So you've got tables which contain rows, which contain cells, and then there's also a set of key value pairs. That's what TinyBase is, basically. A mergeable store contains exactly the same data, but for every cell, for every row, table, and value, there are now also two extra pieces of information. So there's a HLC, hybrid logical clock timestamp, and a hash, which is a unique checksum of the ID of the thing, its content, and the HLC all hashed together. So I guess it's a little bit like a Merkle tree. Those of you that are familiar from that concept in the crypto world. But one thing that's interesting is that the hash is based on a commutative exclusive OR algorithm over its children. So what that means is that when you're adding a leaf or even removing a leaf from TinyBase, it can work the hashes of all the ancestors out incredibly quickly in linear time. And then what I also use, I've had to add this because TinyBase previously, if you deleted something, it was just deleted. I now have a tombstone, which is a very obscure Unicode symbol I found called the object replacement character, FFFC, which indicates that something has been deleted, but it'll stay in the store. For those of you that are not familiar with HLCs, which I just mentioned, here's a quick aside. An HLC or an HLC timestamp is basically a structure that can be used for deterministic timestamps across distributed systems. It comprises three parts. There's a local time based on the system's clock, but it can also get nudged forward to another system's clock if that's further forward in time. A counter of the things that happened within a single timestamp, and then a unique client ID in case two systems ever had exactly the same counter in exactly the same millisecond. So I settle on these limits for storing these in TinyBase. 42 bits, which is 139 years in milliseconds. 24 bits for the counter, which is 16 million things that can happen every millisecond. And 30 bits for client ID, which gives me up to 1 billion clients. I figured this was probably going to be large enough for any given TinyBase installation. But what's cool is that you can serialize that timestamp into a string, and I use a radix 64 encoding. So I basically have 7 characters for time, 4 for the counter, and 5 for the client ID. And the very cool thing about HLC is that this string is now alphanumerically sortable in a way that captures ordinality and causality of changes that happened on different systems, which I think is pretty magical for a 16-character string, but that's how it works. But what that means is that now the merging is super easy. So basically you recurse down within the store whenever the hashes are different, and then when you reach a leaf, you do a simple string comparison on that HLC timestamp, take the highest, and then update the ancestors of the hashes in both stores. It's true. In fact, easy, I would say. Maybe not trivial, but easy. So that's all pretty fun. But I have to say, in terms of implementing this functionality, the data structure, the logical clock, and merge algorithm, yeah, it was all pretty straightforward. And what I would say is there's enough literature, prior art here, to really make this pretty straightforward. The CRDT computer scientists have done a lot of the hard work for us. The hard part, though, at least as far as I found, was figuring out how best to handle stores that are on completely different systems. So we don't really want to have a copy of every store on each system so that we can do that merging in memory. You might be able to get away with that for 2 stores, but moving entire stores between multiple systems so that you can do that full merge in memory will quickly become, a combinatorial nightmare. So basically the question is, what is the synchronization protocol between these systems? And more to the point, what is the most lightweight synchronization protocol so that it doesn't get bogged down with weight and latency? And I have to say, there seems to be a lot less prior art on this topic. There's a little bit, but there's not a lot of conversations about how to make this work, and I kind of had to figure it out for myself. So if you remember, going back to the structure of a mergeable store, it has a checksum hash at each level of its data structure, all the way up to the top. And so right at the top of the data structure, there is a checksum of all the tables in the store, and there is a checksum of all the values in the store. And if 2 systems have the same 2 numbers, then we can say they have equivalent content. And if they don't, then they need to negotiate over what the differences are. And then in turn, if any of the tables have differing hashes, let's negotiate over their differences, and then for rows and then for cells. So basically 2 systems can have a conversation about what their differences are simply by sending very small hashes, basically JavaScript numbers, back and forwards across the wire. To have that we need a protocol. And TinyBase, it turns out this is just a simple set of 8 different messages that the clients can use to communicate. Some of them are broadcast that you send out to all the other clients. Some of them are addressed on a peer-to-peer basis. There's a request response model if you need to have confirmed arrival and responses. But between them, it turns out that this is pretty much enough to negotiate the smallest possible diffs to send over the wire. And I'll give you an example. So we've got 2 clients, client 1, client 2. We start off with client 1 asking for the top 2 level hashes from client 2, and it gets them back. Let's assume that the returned tables hash is different to its own, so it sends its own table hashes asking for the diffs. In return, it gets the entire content of any missing tables and the hashes of any that differ. For those differing tables, it then sends its own row hashes asking for those diffs. In return, again, it gets the entire content of any missing rows and the hashes of any that differ. And then finally, for those differing rows, it sends its own cell hashes asking for those diffs. And in return, it gets the entire content of any missing or differing cells. You apply those, and now everything's perfectly in sync. Okay, so this is why I said that CRDTs are the easy part. This is pretty complicated. It was hard to do. And there's no way I'm going to go through the whole protocol. This is just an example. But I will add a couple of points about it here. Firstly, that conversation probably seemed pretty chatty, but I did work quite hard to make the payloads very small. It doesn't send strings when it can send numbers and so forth. It doesn't always need to be request response like that. So, for example, if a single change is made to a store, it will only broadcast that change at the most granular level needed. And the other stores can apply that silently. We don't have to have that big conversation anytime anything changes. If a conversation is interrupted, no problem. Because the relevant changes and hashes have been updated as we go along, whenever those stores start to chat again, they can just focus on anything that's still remaining to reconcile. And so in theory, and I think practice as far as I can tell, it ends up being eventually consistent with what I think are the right trade-offs between speed and latency, chattiness, and so forth. So it may be me, but I have to say I did find this hard to do. And please don't underestimate what it takes to build and test, especially test, a protocol like this of your own for a local first app. So watching the time here, need to pop back up the stack a little bit. And then this gets me thinking about what is probably best described as a local first to-do list, things that we as a community need to figure out. So it's a kind of a conceptual list, but one thing I think that I really learned during this whole process of building TinyBase from version 5 is that data merging and CRDTs are kind of a solved-ish problem. There's lots of prior art, lots of implementation, lots of literature, lots of computer science, and basically if I build it, I'm tempted to say it's a commodity. But system synchronization, as we just saw, like these protocols can be quite tricky. They're very specific to how the CRDT has been designed. They're getting solved on a stack-by-stack basis, but it's not yet as common in the literature and the prior art. There's not a bunch of computer science. There is no kind of one true way for doing these kinds of things that I can find. I do think we'll get there, but just, something to watch out for if you're starting from scratch. But this is just the top of a long list, right? And there's some more unsolved stuff ahead. And the next one is something that I've got to think of a better name for this, but I'm calling it the management of state management. So let's assume we now know how to store things and how to merge them and how to synchronize them, but when should we do those things? So think about this. In a app, you've got a user, local first app. The user might be online or they might be offline. They might be authenticated or they might be anonymous. I'm sure many of you have enjoyed apps where you're allowed to try it before you sign up. The data might be in a local source of truth stored locally, or it might have a cloud source of truth where it's stored in the cloud, or it might be stored in both places. And then finally, the data itself, let's say a document, might be private to one user, or it might be shared with other people. I had trouble drawing 4 dimensions, but if you can kind of imagine that's the 4th dimension there. So, even with just these 4 dimensions, there are already theoretically 16 different app states. And how and when you need to do the merging and the synchronization across all the boundaries varies with each of these states. And there are some very tricky transitions too, right? What happens if a user is viewing data that's shared by another user and they have a local copy of it, but then they log out? Is that local copy preserved or is it deleted? What if the other user removes your access, but you're offline, so you don't know that, and you can still edit it and still see it? All these different combinations, and that list goes on. I tried building an app to do this called tinyrooms.org, and I tried to explore each of these kind of 16 different states. And I will say, it was a nightmare. Very hard to make sure that the right things are in the right place. And we don't have really any of this complexity with cloud-based apps, because the cloud is the source of truth. You're always online. End of story. But for local first, it can get really complicated, let alone potentially quite insecure very quickly. And the next thing on the list, as if that wasn't enough, is that I worry probably most about at this point product market fit, again, for want of a better word, by which I mean we just don't have enough apps out there yet that we can learn from, that we can be inspired by, and that we see users using in large volumes. So I know there's a demand for the benefits that local first apps bring, sovereignty, flexibility, and of course speed, but where are those flagship apps? Maybe there's 1 or 2, but there should be tens or hundreds of these things. In fact, not just flagship apps, but any local first apps at all, to be honest. And it's cheeky to say, but sometimes it feels like we have more local first data and sync tools than we do actually have apps. Of course, I'm building one of those, so I can hardly talk, but I have been trying. So I recently wrote a local first GitHub client called TinyHub. I'm pretty sure the frame rate of this Discord is not going to show it to its full potential, so I would recommend you go to tinyhub.org and try it out for yourself, or there's a better video in the GitHub repo. So it's an open source local first GitHub client. Pulls the data down at the beginning, and then you can just page through it at the speed of light. It's super awesome, and it was a lot of fun to build, and it's, I think, an interesting glimpse into what the whole local first paradigm can do for us. It wasn't super easy to build, but I learned a huge amount along the way, and I think as a community we just all have to just keep rolling up our sleeves more often, making shovels, and actually go out and dig for gold for a little bit, and we'll find out whether our shovels are good enough. So yeah, that's probably the main rallying cry after everything else today. Build more apps. And I think we continue to have to step up and lead here as a community. And look, this list is never done. If I had another hour, I would talk about a whole bunch of other things that I think we haven't done yet. But these are just a few. We are, of course, at an early stage of local first, and so not surprising. But as ever, I'm continue to be extremely excited by this paradigm, extremely excited about this community, and I'm sure we'll get there. So let's just dream big. Thanks. See you out there.
Wow. This was chat a lot on the side with our like really galaxy brain ideas, and one of this concepts of like what does the essence of items look like in a sort of neural semantic world. And it's something that's exciting to see in terms of like the chimpanzee example, and all the ways that like now we can go from just like a file with text to just meaning and history baked into individual components. So when we merge all of these three talks, we can imagine a world where you have like ever present, multimodal, history preserving, offline capable sync file system. That's just like breaking my brain a little bit. But a lot of talk from our speakers. I'm gonna end the broadcast and recording now. As usual, these meetups are a way for us to get together, chat, and get to meet each other. For those that are in the Bay Area, I've dropped a link. We're meeting up this evening. Stepan is hosting us. This should be